Good evening, Math 7 students. It's been a few days here. Mr. Frechette is finally online, and I'm looking at measures of center. Things have changed in the last 3-4 days. I hope everybody is well and safe at the same time. And I hope everybody is sticking to a routine, staying positive, and trying to have some fun too at the same time. Not only with academics, but with family, and some other things. Don't shy away from playing video games and different things. It's your opportunity to not only do some of the academic stuff that Mrs. Kinney and Mrs. Franks put out for you, but also to go through and be a kid. That's a part of life. So I want you guys all to be safe and be well, but at the same time, we're also going to continue learning. And Mrs. Franks and Mrs. Kinney have already posted a lot of stuff as we start to dive into this statistical unit. So I'm going to talk a little bit about measures of center today. What are measures of center? We work with this every day. You guys see this in your grades on School Tool, and it's just, it's a difference of how you look at it. So what I'm going to say is we have three main vocabulary words we have to look at. We have the mode, we have the median, and we have the mean. So as you can see, the mode is the data or the numbers or the values that occur the most. And we'll talk more about that as we get down on some examples, but that's what a mode is. The median. The median is the value that usually lies in the center or the middle. And that can vary depending on how many numbers or values you have. And in most cases, when we figure out median, we put all our information from smallest to largest. And that's also very important when we're calculating median. So that's one of those things that we do as well. And then mean is probably the one that you guys are the most familiar with. That's just a fancy word for average. You guys know what your average is, and you see your average. Some of you probably look at it daily on School Tool, and School Tool calculates the mean. And the mean is taking values like grades, adding them up, and dividing by a number or the total number of grades that are there. So if you have 5 grades and you add them up and you divide them by 5, you're going to get a mean average or a mean. And that's usually how it's done. We'll talk a little bit more about that later because there's different ways of talking about average and how things show up. A lot of people say that it might be better for us to calculate grades maybe if we look at the median because it maybe is more of a true average, but that's something that a lot of people talk about, and that's kind of something that's a conversation. So as you guys learn this, maybe that'll be something you think about as well when you think about your grades. So without further ado, let's look at exercise 3 here. It says the weights of 15 kittens at a pet shelter are shown below in ounces. So they've already put these values in from smallest to largest. So we're looking at all these values, and it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 values, right? Because we said that 15 kittens, and I was just counting again. I'm one of those people who likes to double check and make sure. So when we look at this, when all 15 kittens were weighed together, their total weight was 207 ounces. So they already pretty much gave you the total for this value or for this data. So, let's skip to B. We don't want to look at the median yet, but B, it says, is the mean weight of the kittens greater than, less than, or equal to the median weight? And how do we know? Justify. So explain your answer. Well, let's take a look. So like I said before, calculating the mean is looking at the total value, which they gave us is 207 ounces. So we're going to look at 207 ounces, right? And we're just going to divide it by 15, right? 207 divided by 15, we get our calculator. I'm actually going to use my cell phone tonight because I had a calculator from school, but I think I just put it aside. So I'll just pull out my my cell phone, which, wow, can't see it. So we'll go to my calculator, and it's a white screen, so we can't see it. But what I'll do is, let me do this. Let me calculate it. I'll put it on my calculator. 207 divided by 15, and that gives us 13.8. So that would mean that the average weight of a kitten, right, would be 13.8 ounces, right? So we can't answer the question yet because we don't know what the median is. Now, median is that value that's in the middle. So what we want to do is we want to go through. Here's a really cool trick going through. You want to cross out the values on each end until you can establish the middle. So we have a 7 and a 7, a 23, a 23, a 9, and a 20, a 10, and an 18, a 10, and a 14, an 11, and a 14, a 13, and a 13. And then we are down to the middle. And when we get down to the middle, that is our median. Okay? So our median for this would be 13, right? So, or 13 ounces would be the average weight per kitten. So is the mean weight of the kitten greater than, less than, or equal to the median weight, and justify? Well, when we look at both values, it looks like that the mean is greater than the median, right? Because 13.8 is greater than 13. Okay, so in this case, or in this calculation, the mean average has a larger, it has a greater value. So, you know, if we were calculating grades and these were grades, we would want to take the mean over the median because it gives you, 0.8 more of a point. So, going through. Let's take a look at this for a second. We want also the mode. We talked about the mode. There's not a question in here, but I want to mention it. The mode is the value that shows up the most. When we're looking here, the value that shows up the most, right? The value that shows up the most is 13, right? Because you get 13 3 times. So the mode in this situation would be 13, which is very similar, right, to the median average and pretty close to the mean average. So as you can see, you see these measures of center are pretty close to a pretty true average. So this data is pretty true. So you're looking at that. So, and like it said down below, the median or the middle number is sometimes tricky to find. That's not the case in this one because we had an odd number of values. It's tricky when you have an even number of values. And, we'll talk about that when we get down below because there's going to be an example down here. So, let me star this. You want to know what this is. I'm going to star this up here because this is what you need to know. And, Mrs. Franks talked about some of that in her notes as well. So we'll get through that as well. But if we scroll up just a little bit, going on to these values, and we look at exercise 4, it says 8 cousins attend a family gathering. Their ages are shown below in ascending order. Basically, you're going from smallest to largest. Now, our data is a little bit different here. We have 8 pieces of data as the information tells us. And they want to know what is the median age of cousins. So we're looking for the middle again, right? And we know that we have 8 values, so we have an even number. And because of that, we know this could be a little tricky. So we're going to still use our same technique. We're going to go 3 and 14, 3 and 12, 5 and 12. And then we notice that, we have 2 values left in the center. So when we have that, we're going to go 8 plus 9, and that equals 17. And we have 2 values. We're going to divide that by 2. So I don't have my calculator up here, so I'm going to use my calculator, on my cell phone. Obviously, I would encourage you guys to use your calculator. If you have it, most of you maybe not have one from school, so you're going to have to use your calculator on your cell phone. And the median in this case is 8.5. So you're looking at 8 cousins attend a family gathering. Their ages are shown below in ascending order, and the average age of the cousins is 8.5. So according to the mean, or the median age. That's the median age. Now let's look at the mean age of the cousins. So in this case, to find the mean, right, mean equals total value. I'll put total value of the data. And that's all divided by the the number of data, or the total number of data. And we can put that over here. So in that case, we go here and we're just going to add it up. It'll just be kind of like adding up a grade, right? We have 3 plus 3 plus 5 plus 8 plus 9 plus 12 plus 12 plus 14, and that equals 66. So that's our total value of the data. That's 66. We have 8 pieces of data. 66 divided by 8 is 8.25. And that would be the average age. So we're dealing with age of the cousins. All right. That's getting a little cockeyed. So get that up so you can see that, and you have that average age, right? So let's take a quick look at one more question, and then we'll be talking more about that as we go along. So you can see this. You can obviously remind it or rewind it and replay it, and go back and look at some of these problems as well. But the question C is also asking us, this data set is considered to be bimodal. What do you think this term means? Well, in the world of English, we can break up our word, and bi meaning, right? You think bicycle, how many wheels does a bicycle have? So you're dealing with 2. In this case, we're dealing with 2 pieces of data. Modal can deal with the mode, or the number that shows up the most, because we know that's what mode means. Shows up the most. And when they're talking about, normal distribution and different things, you got to think of a bell curve. We're going to talk more about a bell curve in a second. That's kind of like what a bell curve looks like. So you have, we call this like a normal distribution. So you have one peak right here. And usually that's where the average is, right here. That's typical. This is normal distribution. But it's a little bit different when we're talking about bimodal. So bimodal has what we call 2 peaks. So you have a peak here and you have a peak here. Think of it kind of like a wave, If you're taking a wave, you have these 2 big waves, and they're kind of bearing down on you when you're trying to surf or whatever, or you're boogie boarding or whatever it is you're doing. So when we look at these 2 things, when we have the 2 peaks, one peak, let's say it represents, let's say these represent test scores, right? So if we have data that's bimodal, we may have a whole bunch of students in class who, there's a large group who get F's on a test, or they fail the test. And we may also have a very large group that gets A's on the test. And that does happen. But that's a little bit different than the normal distribution. You have most of your data in normal distribution over here is pretty much centered around one peak. So that means, the average of a large number of the class, maybe let's say got a 75% or whatever. But bimodal usually brings you 2 peaks. So that means that there's 2 large values that show up in the data. We get a whole bunch of failing grades, but we get a whole bunch of really good grades with an A. And that's something that can happen. But, once again, I want to say, kind of thanks for listening. Stay tuned to YouTube. I have my YouTube channel up and running, and I'm posting my YouTube channels to Google Classroom and Mrs. Kinney's class and Mrs. Frank's class. We're putting a lot of information up there. Take your time going through the work. I mean, do what you can, try your very best, go back and look at the videos, replay them, but take your time as well. Go through. I mean, we don't expect you guys to spend hours and hours and hours on doing homework and only homework. That's not going to happen, or work that you see online. Just do the very best you can, and take your time and go through. And most importantly, be safe, be well. I hope to see everybody back in class very soon, because it is really different being behind a computer screen and a camera, showing you guys different ways to measure statistics. But, everybody be well, be safe, and I'll be tuning in again soon, and I'll see you guys hopefully on Google Classroom. Take care.